Mr. Hissner here, and today what we're going to do is take a look at angle side angle proofs. Angle side angle. Now, again, these are two ways. This is just another way, in addition to the other two ways that we saw, to prove that two triangles are in fact congruent. That the two triangles are in fact the same triangles. They're the same as one another. So that's what we're going to look at today. Now, angle side angle, just like the name implies, that's what we are going to be looking for. That's what we're going to be working with. And so if we look here, we have angle, let me just put, how about this? Angle 1, side 1, angle 2. Notice they go right in succession. Nothing is skipped. It's not angle, skip a side, skip an angle, skip a side, angle. It's right in succession. It's right in succession. It's not, I'm not skipping all around. I'm not going whichever way willy-nilly. I'm going right in succession. And so our proof here is, it looks like we have angle A is congruent to angle D. We have segment AB is congruent to segment DE. And finally we have angle B is congruent to angle E. And then our congruency statement is a triangle, and it's all the corresponding parts. So it's triangle ABC is congruent to triangle DEF. Again, all corresponding parts, which is something we should be familiar with by now. And let's look at our first proof. So what we have here is we have a bisector. Now this bisector is going on to two angles. So we have this segment and it bisects two angles. It bisects RQT, so the angle on the left, and RST, the angle on the right. Now, bisectors, let's have a discussion. Bisectors do something to an angle. It cuts it directly in half. So if SQ is our bisector, that means that it's cutting this angle in half. So when things are cut perfectly in half, they are the same. So we're going to have angle RQS is congruent to angle TQS. So these two angles here in yellow, angle 1. And also it's a bisector of the angle on the right, that big angle. And so it's going to have this sort of half angle here. So angle RSQ will be congruent to angle TSQ. And again, that is because this is a bisector, right? So it's going to have kind of these two parts are going to be the same there. And likewise on this side. And then how can we wrap this proof up? Well, it looks like there's this reflexive side. Reflexive, possibly symmetric. We'll have to look at how exactly we're going to write this or how it is written. And that's basically what we have. So the bisector makes these two angles congruent, angle, angle, side, and so it's angle, side, angle, just like that. So let us look. So this bisector is given to us, given, and so we have these two angles are congruent. Hey, isn't that what we said over there? RQS and TQS, they're congruent. Why? That is the definition of a bisector. That's what a bisector does. That's the definition of a bisector, an angle bisector. Hey, again, RSQ, TSQ, isn't that what we wrote? Yes, it is. RSQ is congruent to QST, TSQ. And again, that's the definition, once again, of this is an angle bisector. That's what an angle bisector does. It cuts an angle in half. It makes two angles congruent because it bisects them. It slices them right down the middle. And then finally, we have QS is congruent to QS. So QS is looking at itself in the mirror. This is reflexive. And so here we go. Now we have our side, no, our angle, side, angle. These two triangles are congruent. Why? Because angle, side, angle, triangle congruency. So again, the idea here is going to be looking for these types of things. Bisectors make angles congruent. What else makes angles congruent? Vertical angles make angles congruent. What are those? Alternate interior angles, right? Parallel lines make things congruent. So we have these ways of making things congruent. So just be on the lookout for those, and yeah, use those as your angles.